Today we're solving systems of linear equations graphically. A system of linear equations is a set of two or more equations which have variables in common. Okay. The solution of a system of linear equations is the set of values for the variables that make each equation in the system true. Graphing the system can show what appear to be the solutions. Okay, and this would be the point of intersection for the two equations. So here we have two equations that we're going to be putting together. When you have this little loopy thing next to it, that means it's a system of linear equations. Okay, so first thing we have to do is make sure both of our equations are in slope-intercept form, which we should know is y equals mx plus b. Okay, so my first equation here, I'm going to put in slope-intercept form. Okay, so here it is. I want to end up with my y alone on one side of the equal sign. So I'm going to subtract 5x from both sides. And I'll get this. I'm going to put this in front because that's the form that I'm looking for. Okay, I'm still not done because my y is not alone. So now I'm going to divide everything by 2. So if I do that, here's my equation. And this is easy for me to graph, right? I've got my y-intercept at 0, 3. So I'm going to graph that. 3. It's right there. Okay. And I've got my slope, which is going down 5 and over 2. Okay. So that's my first equation graphed. Okay. My second equation, x equals 2. Well, what kind of a line is that going to be? Where x always equals 2? Where x always equals 2 is going to be a vertical line, right? With no slope, right? Okay. Can we see where it intersects, where it appears to intersect? It appears to intersect at 2, -1, okay? That appears to be the point of intersection. And so we just solved it graphically. So that's our solution, okay? There are more exact ways to solve these that we're going to learn later on in the week, but this is the first method that we're using. So this is our solution, okay? All right, so we have different types of systems of equations. So you're going to have to know how to label these systems, okay? If it's consistent, that means that there is at least one solution for the system. We call that a consistent system of equations. An inconsistent system means that there is no solution, okay? So if you had two parallel lines, would they ever intersect? No, that would be an inconsistent system, okay? An independent system basically describes two different lines that intersect. They intersect, okay, at some point. A dependent system means both equations describe the same line, okay? So if you put them into slope-intercept form and you come up with the same exact equation for both of them, then that is a dependent system. That means that, and it's also consistent, okay? It's the same line, the exact same line, okay? Let's go to the back. All right. When would a system of equations have no solution? That would be when the lines are parallel. They will never, ever meet. So there's no solution to that system, okay? So let's look at these two equations that are forming our system and put them in slope-intercept form and graph them and see if we can find a solution. So my first one, 4x plus 5y equals negative 20. I need to put that into slope-intercept form, which of course is y equals mx plus b. So if I do that, I'm going to be moving this 4x over here by subtracting it from both sides. I want to put it first, so it'll be as close to that form as I can. Okay, over here now, I still have my 5y. I want my y to be completely alone, so I'm going to do the opposite of multiplication. I'm going to divide everything by 5. And if I do that, then I've got y equals negative 4/5 x minus 4. So now this is pretty easy for me to graph. Okay, my y-intercept is going to be at 0, negative 4. So that's the first point for me to graph. Okay, I'm going to use my slope, which is rise over run. So negative 4, so down 4, and over 5. 1, 2, 3, 4, 5. Okay, so now that's my first line. I really recommend that you use a ruler for these when you're trying to solve them graphically because it makes it much easier to be exact. What I'm doing here isn't very pretty or exact. So, okay, next we're going to put my other one into slope-intercept form. So I'm subtracting 8x from both sides. I'm going to move this in front. Okay, now over here I've got 10y. I'm still not done. Now I have to divide everything by 10. So now I've got y equals negative 8 over 10x plus 4, which can be simplified, right? If I simplify this, I'm going to get y equals, what can we simplify this to? 4, negative 4/5 x plus 4. Is that the same line? Well, let's take a look. So we have our y-intercept is at 0, 4, which means it's up here. And our slope is the same slope as our other line. Does everybody see that? Same slope. When you have the same slope, what does that tell you about those two lines? Does anybody remember what that is? So we're going to go down 4 and over 5. Here's my second line. Okay, sorry, that's a horrible drawing. But these are parallel lines. They will never meet, okay? So does this have a solution? The system? No, this has no solution because these lines are parallel, okay? No solution. All right, let's look at our last example. We have to put this into slope-intercept form, both of them, so let's do that. Here's our first equation. So I'm going to subtract 6x from both sides. And then I'm going to move it to the front because that's going to get it into our slope-intercept form. And now I need to divide by negative 10 on both sides. Okay, and when I do that, I'm going to get y equals, this is going to become positive because a negative divided by a negative. Okay, and then I can reduce it, right? So that'll become 3/5 x plus 2. Okay, so now I can graph this. And when I do, so my y-intercept is at 0, 2. So it's right there. Oops, and then I'm going to use my slope. So I'm going to go up 3 and over 5. Okay, so that's my first line. My second line that I need to put into slope-intercept form is kind of weird looking. If That doesn't matter. We can still do the same thing to it, okay? So here we have our second line of there. Okay, so I want to flip this stuff around, right? So the first thing I'm going to do is I'm going to add y to both sides. Okay, so I get y minus 3/5 x equals 2. Now I'm going to add this, because I'm always using the opposite operation when I'm solving an equation, right? I'm going to add 3/5 x to both sides. And then I've got y equals 3/5 x plus 2. All right, what do you notice is going on here? Here is our first line. Here is our second line. They are exactly the same. So they have the same slope. They have the same y-intercept. So guess what, guys? It's the same line. So if I was going to plot this point again and use my slope, I would get exactly the same exact line, okay? So how many solutions are there to this system of equations? When they're at the exact same line, that means that there is an infinite number of solutions because all of the points on the line match up both directions, okay? So we have an infinite number of solutions. That's when both of the lines in your system are the same line, then you have an infinite number. Okay, bring your notes to class tomorrow and I'll see you then. Bye.